Everyone, I am Dr. Biswajit Mahanti, Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. Today, I am going to discuss about the course name is Information Theory and Coding. So, course name is Information Theory and Coding. So some numericals I will going to discuss here. Those are very useful for semester exam, mid-sem or any competitive exam, GATE exam. So first coding technique I am going to discuss, that is Shannon Fano coding. Shannon Fano coding. So we will practice some numerical based on Shannon Fano coding. So let us take one example, one numerical, that is x is there and the messages are x1, x2, x3, x4, x5, x6, x7, x8, and corresponding probabilities are, the first one is 1 by 4, second one is 1 by 8, 1 by 16, 1 by 16, 1 by 16, 1 by 4, 1 by 16, 1 by 8. So these are the probabilities. Now what we will do? We have to arrange. See, the probabilities are not in the ascending or descending order. They are in abrupt, haphazard order. 1 by 4, then 1 by 8, 1 by 16, 1 by 16, 1 by 6, again 1 by 4 came, again 1 by 16, now again 1 by 8 came. So the process is, first we have to make arrangement of higher probability to lower probability. We will arrange and make a table, and corresponding messages we have to write, corresponding messages. So let us start. Here m is equal to 2. Here we taken m is equal to 2. M is equal to 2. Why 2? Because we will code all the probabilities with 0 and 1, combination of 0 and 1. So binary, 2 number, 0 and 1. So that's why m is equal to 2. So let us make a table. So first is, so we have to remember this problem, x values, x1, x2, x3, x4, x5, x6, x7, x8. So 8 number of messages are there and corresponding probabilities are given. So what we do, we can make a fraction, or we can start with this without making any fraction, or whatever the value is given in that way. Okay, or we can start with fraction values. So I will not make fraction number. So whatever the values is given, I will arrange accordingly. So the first column is message. Second column is probability, and probability is equal to, I can write pi, and encoded message. This is important, encoded message. And the third one is length, or length, length, ni. So this is the table. So what are the probability? Highest probability is 1 by 4. 1 by 4. How many 1 by 4? 2 1 by 4. So 1 by 4, 1 by 4 first. Then what we will make after 1 by 4? 1 by 8. 1 by 8, again 1 by 8. How many 1 by 8? 1, 2, 1 by 2. And how many 1 by 16? 4. 1 by 16, 1 by 16, 1 by 16, 1 by 16. So now what are the messages? This is x1, this is x6, this is x2, this is x8, this is x7, x3, this is x4, x5, and this is x7. From here I can map. Now, what is the first target? First target is that we have to make it two group of equal probability. Now, suppose if we add these two, what will happen? The probability half, 1 by 4 plus 1 by 4. If we add all those, what will be the total probability? 1 by 16. This 1 by 16, 1 by 16, 1 by 16. So 4 into 1 by 16, that means 1 by 4. Plus 1 by 8, 1 by 8 if we add, so it will be 1 by 4. So 1 by 6, 4 into 1 by 16, we are getting 1 by 4. 1 by 8 plus 1 by 8, it will give you 1 by 4. So this is 1 by 2. So that means this side gives 1 by 2 probability. Here also we are getting half probability. So that means we can divide two parts. These two gives half, and these all 6 gives half probability. So this group and this group are equal, probability are same. But luckily here we get the same probability. Sometimes it may not happen. Sometimes these two probabilities may be the as close as possible, like this only. Okay, so now we will make it clear. To make you understand, I have shown the additions. So make it clear. Just simply we are making it clear, and we will start again the solving the numerical. So we will make a two group of equal probability. Is it clear to you? So now hope you have understood. So now this is 0 group, this is 1 group, another group. All elements are 1. Now again we make, this is again classification, this is 0 and 1, because these two are having same, so we can make this is 0, this is 1. Now again the remaining, this remaining we can make two parts, because 1 by 8 we can make like this group, 1 by 8, because 1 by 8 is 1 by 4, and 4 into 1 by 16, these will make 4 into 1 by 16 will make 1 by 4. So these two are the same. So that's why, make it clear. So now again all are ones. Now we can make two groups again. So this is again 0 group, this is 1 group. Again we can make these two same, so again we make 0 group, this is 1 group. Now here in the bottom we can make again two groups, this one, because 1 by 16, 1 by 16, it will give you 1 by 4, these two. So these two, if we add these two, 1 by 16 plus 1 by 16, here also 1 by 16, 1 by 16. So that means both are same. So that's why we made one more group here. So this is 0 group, this is 1 group. Again we can make 0 and 1, this is also 0 and 1. So in this way we made a group and we got the binary numbers. Now we have to calculate the length of each code. For x1, which probability is 1 by 4, we get 00 code, encoded message. So this is 0, x1 is for 00, x6 for 01, x2 for 100, x8 for 101, x3 for 1100, x4 for 1101, x5 for this x5 for 1110, and x7 lastly 1111. So now we'll count the length. The last column is length. So for x1, both are 00, so length is 2. This is 01, length is 2. 100, length is 3. This is 101, length is 3. Here 111, 1100, so 4. Here 1 1 0 1, so again length is 4. Here 1 1 1 0, length is 4. 1 1 1 1, length is 4. So last 4 having the length 4 4 4 4, and x2 and x8 length is 3, and x1 x6 length is 2 2. So now this is the final table. Now based on this table we will make some calculations. So these calculations are most important. So what are the calculation? We will go the average code length. This is the code length for individual. So now we will go for average code length. So we can summarize it. Message probability pi, and code length li, this one. So x1 giving 2, x6 giving 2. x1 probability is how much? Half. This is 2. Again x6 half giving 2. Now others say how much? 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 16, 1 by 16, 1 by 16, 1 by 16. So this is x6, then x2, then x8, x3, x4, x7. Now this is 2 2, this is 3, this is again 3, then all are 4, these are 4. So now we will calculate the average code length, that is L bar. Average code length L bar, that is equal to formula summation over I is equal to 1 to 8. How many numbers are there? 8 number of probabilities are there. So pi li. So if we calculate it, it will be 1 by 4 into 2 plus 1 by 8 into 3 plus 1 by 16 into 4 plus 1 by 16 into 4. This is probability into length. 1 by 16 into 4 plus 1 by 16 probability into code length 4 plus 1 by 16 into 4. How much 16? 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7. One more is 1 by 8 into 3. So if we add together, so that will give you 2.75. What should the unit? Letters per message. So L bar is equal to 2.75 letters per message. Now we'll go for calculating entropy H of x. So that is most important. That is here minus I is equal to 1 to 8 p of I log to the base pi. That is the formula. Mean probability into log to the base probability. So now we can shorten, because here 1 by 4 is single, 1 by 8 is 2, 1 by 8, 1 by 8. Here 16, 1 by 16 is probability 1, 2, 3, 4. So we can shorten like this. Minus is there. So 1 by 4 into log to the base 1 by 4 is okay. So one thing we can do is pi is this, log to the base 1 by pi. So plus 1 by 8. How much? 1 by 8? 2 into log to the base 1 by 8 plus 1 by 16. How much? 4 into log to the base 1 by 16. So if we calculate it, this entropy, if we calculate it all those, so that will give you, that is also 2.75 letters per message, letters per message. So now we therefore efficiency eta is equal to hx by L bar log to the base m. Here m is equal to 2. Then hx L bar log to the base 2. So hx is L bar into 1. Log to the base 2 is equal to 1. So hx by L bar. So hx is 2.75 divided by L bar also 2.75. Okay, that is 100%. So efficiency is 100% here. So it's a very nice example. We got efficiency is equal to 100%. So that is a very beautiful numerical. So my dear students, practice such kind of few more numericals and get ready for the our respective exams, mid sem, end sem, or gate exam, any other examinations. So we may set few more numericals. Problem number 2 also we can do. Problem 2, one more. Okay. So let us another numerical. That one I am taking one more numerical. Here Shannon Fano coding again. Shannon Fano coding. Taking one more numericals. What is the numerical? Is x is equal to x1, x2, x3, x4, x5, x6, x7. Probabilities are here. The fraction is given 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. So these are the probabilities. But here the advantage is that in this numerical, here the probabilities are higher to lower. Already it is arranged. So we no need to arrange again. So what is the first column is message, solutions. I am going for solution. Message, then probability, pi, then encoded message, last is code length, li. Okay, so now message is normal x1. So I write the probability first, 0.4, 0.2, 0.12, 0.08, 0.08, 0.08. How much 0.08? 1, 2, 3. And the last one is 0.04. So this is x1, this is x2, this is x3, this is x4, this is x5, x6, x7, this is 0.4. Now what we will do is that we will make a group of two equal probabilities. Okay, so if we add these all, it will give you 0.6 and this is 0.4. So we will make two groups because this is 0.4 and this is 0.6. This is the minimum distance between these two groups. We can't arrange two groups so that the probability should be less than of that difference. The minimum difference between two groups is 0.4 and 0.6, that is 0.2. So what we will do, that we will make a group of these two, and first group should be 0 and second group should be 1. So we can make this is 0 group and these all are 1 1 1 1 group. Again what we will do, that this is 0 group, this is 1 group. Sorry, here 0.2 and 0.12, 0.2 0.12, we are making one more group. So this is 0 group, this is 1 1 1 1 group. So we can make group 0 and 1, this one. Now here again we will make these two group, this is 0 group, this is 1 group. So again we make it 0 group, it is 1 group, and again we will make it 0 group, this is 1 group. So step by step, two group, and each group 0 and 1, like this. Now what will happen here, this is 0, length is 1, here 1 0 0, length is 3, here also length is 3, here length is 4, here also length is 1 1 0 1, length is 4, here also length is 4, here also length is 4. So all the cases except first three, all are 4. Okay, so now what we will go for calculating, we will go for calculating the average chord length, that is L bar, and L bar is equal to summation over, okay, I is equal to 1 to 7 here, because 7 number of probabilities there, Pi Li. So now P1 L1, so what is that, 0.4 into first length is 1, because 0.4 is the probability and length is 1, 0.2 3, 0.1 3, like this we will make average chord length. So that is 0.4 into 1 plus 0.2 into 3 plus 0.12 into 3 plus 0.08 into 4, next 0.08 also having 4, plus next 0.08 also having 4, and so how many 0.08, 1 2 3, all are 4. So 1 2 3, the last one is 0.04, that is also 4. So what we get is that together it will give you 2.48 letters per message. Now we will calculate entropy. Now entropy Hx is equal to, formula we know that I is equal to 1 to 7 P of I log to the base Pi. So in this case it should be minus is outside, Pi log to the base Pi. So Pi is 0.4, the probability, into log to the base 0.4. Similarly this is 1, similarly 0.1 0.2 into log to the base 0.2. The third one is 0.18 into log to the base 0.12 plus others are 0.08 into log to the base 0.08. So this one again 0.08 log to the base 0.08. This one again 0.08 log to the base 0.08. So 3 0.08 and last one is 0.04 into log to the base 0.04. So this is, now if we calculate together, it will give you h of x is equal to minus 2.42 bits per message. So we can write hx is equal to h of x is equal to 2.42 bits per message. So we get L bar is equal to, what we get? L bar is equal to 2.48 letters per message, and we get h of x is equal to 2.42 bits per message. So now hence the efficiency eta, that is equal to h of x L bar log to the base m, and we know that here m is equal to 2 because we are using 0 and 1 only, binary. So that will give you log to the base m log to the base 2 is equal to 1. So that will make efficiency eta is equal to hx by L bar into 1. So hx is equal to 2.42 divided by 2.48 as L bar. So that will give you 97 point, if we calculate it, it will give 97.6%. So that is efficiency. So now we can make one more calculation, that is redundancy is equal to 1 minus eta, that is 100% minus 97.6. So that is 4 2. So that is 2.4%. 2.4% is the redundancy. So that is all about. So finally we can calculate what is L bar, what is h of x, what is eta, and what is 1 minus eta. So L bar is 2.48 letters message per message, h bar is 2.42, I think 2.42 bits per message, eta is equal to 97.6%, this is 2.4%, 1 minus eta, redundancy, that is redundancy. So this is all about our final result. So these numericals are very, very important for mid sem or end sem. So hope you people understood the Shannon Fano coding. So these are two important, problem 2 for Shannon Fano, and this is problem 1, Shannon Fano coding. So these are very much important. Now we'll solve the same problem with m is equal to 3. With m is equal to 3. So what are the probabilities? x1, x2, x3, x4, x5, x6, x7. What are the corresponding probabilities? 0.4, 0.2, 0.12, 0.08, 0.08, 0.08, 0.04. Here is the message. Here is the probability encoded message or bit. This is length, bit length. Okay, so now the bit length. So this is the heading title. Now m is equal to 3 means here 3 levels will be there. Earlier 0, 1 and 1, 2 levels we have divided. Here 3 levels means 0, 1, 2. Here we will make 3 levels. So here 4.4 is one group, 3 groups. These 2 are one group, and these fours makes another group. Because m is equal to 3. So now we will make it m is equal to 3 means 0, 1 and 2. 3 codes will be there, 0, 1, 2. So this is 0 because single 0.4. Now 0.2 and 0.12 is there. It should be 1, 1. And this last group 0, 1, this is 2, 2, 2 and 2. Now this is 0, now 1, 1 is there. So this 1, 1 we may divide again this 1, 1 as this is 0 group, this is 1 group. Okay. Now here all are 2, 1, 2, 3, 4. So here also we make 2 groups, 0 group, 1 group and 2 group. So what we will do? 0.08 is 0 group. This one, this is 0 group, this is 1 group. 0 and 1. And this is 2 groups. So 0, 1, 2. Now this is classified. Now we will make this one. This is 0 and 1. Because only 2 are there. So what is the case length here? For first x1, this is 0, this is 2, this is 2, this is 2, this is 2, this is 3, and this is 3. Okay. So here if m is equal to 3, then the process is something different. We have to make all the probabilities, we have to divide all the probabilities with 3 groups. Like here initially what we have done is that this one, this 0, 1, 2. Now it is 0, so no change. This 1, 1 we made 0 and 1. For these 4, 2 we made 3 groups here also. This is 1 group, this is 1 group, and these together 1 group, last 2. So that's why this is 0, this is 1 and this is 2 group. And 2 group we can divide with 0 and 1 another group. Okay, so we got the length Li, this is the probability Pi. So again we will calculate L bar. Again we will calculate L bar. So L bar, what is the formula? As I mentioned, summation over I is equal to 1 to 7 Pk Nk, or means Pi Ni. That is 0.4 into, sorry, this should be 1, not 0. This is 1. Length is 1. So 0.4 into 1 plus 0.2 into 2, 0.2 into 2 plus 0.12 into 2 plus 0.08 into 2 plus again 0.08 into 2 plus 0.08 into 3, and last one is 0.04 into 3. So if we calculate it, it will be L bar is equal to 1.72 letters per message. Okay, and hx is always same. Hx again here also it should be 2.42 because probabilities are same, these bits per message, so there is no change of entropy. So efficiency eta should be hx by L bar log to the base 3, because to the base m, so that will give you 2.42 1.72 into log 3 to the base 3. So if we calculate, it will be 88.7%. So efficiency eta is equal to 88.7% here. So this is all about Shannon Fano coding, and these are very much important. So just try to see if the number of bits are changes to code and we will solve. So after that you practice all those Shannon Fano codings, and I will give you one practice that is, you can do is so practice problem. X x1 x2 x3 x4 x5 x6 x7, and probabilities are 0.2 0.2 0.15 0.1 0.1 0.05 and 0.05. So this probability is given for 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Something is missing. Okay, I am writing second again. Some values may be missing. So first is 0.2, 0.2, 0.15, 0.15, 0.1, 0.1, 0.05 and 0.05. So these are the values. So here I am giving you the L bar. You have to find out L bar, h of x and efficiency eta. So 3 you have to calculate. Okay. So thank you. We'll come back with new videos, and there I will discuss about Huffman coding. Till then, stay tuned. Thank you.